Hello there, welcome to the June 2019 paper. Here we're looking at question 8. A gas company maintains a straight pipeline that passes under a mountain. The pipeline is modelled as a straight line and one side of the mountain is modelled as a plane. There are access ways from a control centre to two access points on the pipeline. Modelling the control centre as the origin O, the two access points on the pipeline have coordinates P and Q where their units are in meters. Find a vector equation for the line PQ, giving your answer in the form r equals a plus lambda b. Okay, so r equals, let's start at point P, minus 300, 400 minus 150. And then let's work out how we're going to get from P to Q. From P to Q on the x variable, we're going to have to go up 600. From 400 to 300, that would be down 100. And from minus 150 to minus 50, that would be up 100. And we could simplify the direction vector there. You can't simplify the starting coordinate there because that is a starting coordinate. But you can simplify the direction and just scale factor it down as long as it's travelling in that same direction of 6 minus 1, 1. So there we are, that's the answer to part A. Let's move on to part B. The equation of the plane modelling the side of the mountain is 2x plus 3y minus 5z equals 300. The company wants to create an access way from the side of the mountain to the pipe. The access way will consist of a tunnel of shortest possible length between the pipeline and M, which has coordinates 100, 100k, 100 on the side of the mountain. Using the model, find the coordinates of the point at which the tunnel will meet the pipeline, the length of this tunnel. Okay, so first of all then, let's work out what this k value is going to be in coordinate m. Now given that m is a point on the side of the mountain, and the side of the mountain has this equation at the top here, we can work out k using that. So it's going to be 2 times 100, so 200, and then k times 3, so 3k, and then minus 500 equals 300. So that's going to mean that 3k equals 600, so therefore k equals 200. So therefore we now know that coordinate m is equal to 100, 200, 100. Okay, so now what we want to do is work out the shortest possible length from this coordinate here to the equation r, and equation r from before had equation minus 300, 400, minus 150, and then plus lambda lots of, I think it was 6, I think this one was minus lambda, and this one was lambda. Just check. Good, right, okay, so what we want to do then is shortest distance from a point to a plane. So what we'll do then is we'll refer to this point here, the point of connection, the coordinate which the tunnel will meet the pipeline. So there we are. So this is I'm referring to coordinate I here, the coordinate of the point at which the tunnel will meet the pipeline. I'll refer to that as minus 300 plus 6 lambda, 400 minus lambda, and minus 150 plus lambda. And we want to find the shortest distance to this coordinate up here, 100, 200, and 100. Now, first of all, it would be helpful to work out the direction vector from one vector to another. So what I'll now do is, if I call this, that's point M, I'll refer to this as point P. So if I now work out the coordinate from M to P, then that's going to be minus 300 plus 6 lambda, 400 minus lambda, and minus 150 plus lambda, minus 100, 200, 100. So that's how you get from m to p. You do p take away m. So let's now do the subtraction. It's minus 400 plus 6 lambda, and then it's going to be just 200 minus lambda, and then minus 250 plus lambda. Right, so now what we're going to do is we're now going to do the dot product of the line M to P and the direction vector of this line here, because this should meet at a right angle. So therefore minus 400 plus 6 lambda, 200 minus lambda, and minus 250 plus lambda. We'll do the dot product with the direction vector of the pipeline, which is 6 minus 1, 1, and that should equal 0. So let's expand the brackets. It's going to be minus 2,400 plus 36 lambda, minus 200 plus lambda, and then minus 250 plus lambda equals 0. Let's simplify all of the lambdas. That'll be 38 lambda, and then move all of the numbers onto the other side. So it's going to be 2,400 positive on the other side, 200 positive on the other side, and 250 positive on the other side. That's going to give us 2850. So then divide lambda by that. So it's divided by 38. We get 75, yes. Okay, that's a positive whole number. That definitely kind of makes sense. So, therefore, the coordinate of the point at which the tunnel will meet the pipeline, so now we'll just put lambda into this point here. So the answer to I is equal to minus 300, minus, let's do this on the calculator, minus 300 plus 6 times 75, and that's 150. 400 minus 75 is 325, and minus 150 plus 75 is minus 75. So there we are, that is the coordinate. And the length of the tunnel, now we'll substitute lambda into this one here, M to P, and then work out the magnitude of it. So M to P is going to equal minus 400, add 6 times 75, which would be 50. That'll be 125, and then minus 175. So let's now work out the magnitude of this, MP. So it's a Pythagoras calculation now. I'm not going to write it down because I think I'll run out of space then. 50 squared plus 125 squared plus 175 squared equals 28 root 75, or 221 meters if we round to the nearest meter. So there we are. There is the point of connection onto the pipeline, and the length from the point M to that pipeline is 221 meters. So there we are. Let's now move on to parts C and D. It's only practical to construct the new accessway if it was significantly shorter than both of the exit ways OP and OQ. Determine whether the company should build the new accessway. Okay, so these are the 2 points here, P and Q. So let's work out the magnitude of O to P. So OP, magnitude of that line is going to be 300 squared plus 400 squared plus 150 squared, and that will give us an answer of 522 meters. And OQ is going to equal the square root of 300 squared plus 300 squared plus 50 squared, and that's going to give us a distance of 427. So it looks like the 221 meters is much shorter than these two pipelines here, OP and OQ. So 221 is much shorter. So the company should build the new accessway. And there we are, that's the answer to part C. The answer to part D is going to be any reason why these assumptions wouldn't probably be true. So, for example, the rock foundation might not allow you to drill in the tunnel in a straight line, or the tunnel, the rock face may not be may not be accurately represented as a plane. It would probably have bumps and peaks, etc., etc. So any kind of explanation that would describe why any of these assumptions would not be true. So there we are, that's the answer for question 8 there. Let's now move on to question 9.